Okay, welcome back to part 2. This time we'll have a look at some applications of that knowledge that we just developed. So the first term is 8, so that's A1 in our list. The common ratio R, and it wants the first 4 terms. Okay, so A1 is 8, so that was given in the question. This is quite common. A2 is A1 times R. Okay, so we'll do 8 times minus a half, which is minus 8 on 2, which is minus 4. So there's our second one. So we've got 8 minus 4 so far. A3 is the first term multiplied by R. 3 minus 1, which is A1 times R squared, which is A1 is 8 multiplied by bracket squared minus 1/2. Now the 2's go down, don't they multiply? So that's 1. And down here, so that'll become 4. The minus, if these are even, then the minus sign evaporates. Okay, so here we'll have 8 times 1/4, which is 8 over 4. Just doing all the steps, which is 2. So the next one was 2. All right. A4 is equal to A3 times R, or it's equal to A1 times R4 minus 1, which is A1 R3. A3 was 2, and the common ratio is minus a half. So it's going to be minus 2 over 2 minus 1, or we're going to go for 8 times minus a half cubed. Now, when it's odd, minus stays, doesn't evaporate. Okay, so we're going to get 8 times minus the 1 and the 3 multiply, so you get 1 to the power 3, which is 1, and the 1 and the 3 multiply, and you get 1 times 3 is 3, so it's 2 to the power 3, and so we get 8 minus 1 over 8, because 2 2's 4, 2's 8, which is 8 over 8 minus, which is minus 1. So that matches what we did in the other method. Okay, so it's the same. It's the same. Happy days. All right, so a little bit of pre-work. I don't think this is terribly onerous, is it? I think we can do these fairly well. Okay. All right, find the 9th term, A9. This is the first term, A1, and so on and so forth. We haven't worked out the ratio, so it shouldn't matter. As long as we do the 1 and then the previous one, 1 and then the previous one. So they're the pairs, you know. So we can do 3 is 9 on 27, which is 3 9s are 27. So that's 1/3. All right. So the next thing we can also do is 27 on only 1. Don't know why we do this. 3 9s are 27. 9 9s are 81. They'll cancel. And we get 3 on 9, which is 1/3. There you go. So that's very, very straightforward, isn't it? They're both 1/3. Okay, so we're going to do the 9th term. So we can do A1 times R to the 9 minus 1, which is 81 times R to the 8, which is 81 times 1/3 to the 8. Okay, so we're going to get, now 9 9s are 81. Now I'll just do this a little bit first. 9 9, I'll just do it like that. I don't know why I'm being annoying, but So the 8 ones are 8. 1 to the power 8 is 1. And 3 to the power, that's a 1, so it's times. So 8 ones are 8, so it's 3 to the power 8. I think this is why I'm doing this. These are also 3s, aren't they? 3 is a 9. 1 over 3 to the 8. So that's all 3 to the 4. Times 1 over 3 to the 8. We can subtract those. So 4 minus 8 is 3 to the minus 4, which is 1 over 3 to the 4, which happens to be what we did up here. There it is, 81. So it's 1 over 81. All right, so we can use, I did it all without a calculator. Okay, we can use our techniques to give us values. So I think it's just a reminder that we can use these values. Okay, we'll get to the science a bit more in a moment. All right, so of the first 6 terms, first term is 3. Oh, it's given us A1 and the ratio, the half. Okay, so the sum of the first 6 terms is the first term 1 minus R6 over 1 minus R, because it's now wanting the sum. So 3 times 1 minus a half to the power 6. So it's always the same gymnastics, isn't it? 1 minus a half. Half. So we've got 1 to the power 1. So it's 1. 3 times 1 minus 1 to the power 6 over 2 to the power 6. That's what this times actually does. We should be careful of that. And 1 minus a half is just a half. So 1 to the power 6 is simply 1. 2 2s are 4 2s are 8 2s, 16 2s, 32, 64. So 1 over 64 and a half. Now, if we divide by a half, that's divide by a half times by 2 over 1. So we can multiply this top line by 2. So 2 times 3. Now, 1, what's the form of 1 to complete this? 64 over 64. We get 64 over 64, same family. Working beautifully. So 2 times 3 and 64 minus 1 is 2 times 3, 63 over 64. Okay. I think the reason I've left that out is because I can divide this. 3 3s are 9. 3 6s are 18. 189 over 32. So what are our values? Okay, the first 6 terms. Why are we doing this? Well, we've gone beyond high school now. Does the plane stay aloft and fly safely? Does the car not crash when it goes around a corner or break? Does the baby live? What's the mortality like? Have the cancer rates decreased? Has the treatment for a cancer reduced the morbidity of that particular cancer? Do the buildings stay standing? Do the rockets go higher and higher and higher? So all of these things are the results of being able to manipulate sequences and sums. All right, so the analysis of the science is quite high. All right, so for our how many terms, now they want an answer. So we're saying the sum is 1093, so n is unknown. So Sn is equal to our first 1 minus r to the n. So we can work out r. So 27 over 9 9 over 3, 3 over 1. So it's quite evident that r is equal to 3. You can do your ratio check. So r is equal to an divided by the previous term. So 3 divided by 1 is 3. Alright, so for this one here, what we're going to do is we've already been given 1093. We have r, and we're looking to get that in. Okay, so we get 1093. Now that's 2, isn't it? Let's do it this way, 1093. Now the 1 multiplied 3 is just going to be expansion. Because it's times 1, it's not going to change anything. And we're over 2 now. So multiply both sides by 2. And we will get 2186. 1 minus 3 to the n. Now I might subtract 2 or add. Wait a minute. It's minus 2. 1 minus 3 is minus 2. Be careful. Minus 2. So multiply by minus 2. They will cancel. But this is now minus 2. So it's minus 2186. So I might add 2186 to both sides. And I might add 3 to the n to both sides. So that'll give me 3 to the n is equal to 2186 plus 1 is 2187. So how do we get to n? We undo. That should be the thing, the instinct that screams out, undo. So we take log base 3. That's our undo. That's our 1 times n. And what you do to one side, you do to the other. So n is equal to log base 3. And I hear you say, hang on a minute, we can't do that on the calculator. Well, we use the change of base. So that becomes log or ln 2187 divided by ln 3. So if I get the calculator, just bring it into view. Ln, so 2187 and divide that by 3 is equal to 7. So n equals 7, and that makes perfect sense. N equals 7 is the number of terms needed to give the GP a sum of 1093. So we should probably write that formally, shouldn't we? Therefore, 7 terms are needed for Sn to equal 1093. Beautiful. Okay, now one of the things we'll do there, I think, is we'll continue on, and we'll do this little bit, I think, because we kind of already did touch on it to some degree. Okay. Now these partial sums mean, of course, that what we have is partial sums, but it's possible for us to have infinite sums. And I sort of did that in the introduction, a bit cheekily, some meta knowledge about what happens. But you know what I'm going to do? I'm going to pause the video here for part 2, and because we're going to introduce another topic called limits, so I'm going to have a look at that in the next video. So we'll be back soon.